is about optimizing custom code and plugins with the Common Data Service. And as many of you may know, plugins have been around for a long time, and they are one of the fundamental building blocks for building solutions on top of Common Data Service. While these days there are a lot more options that you can use to add business logic to your application, there's still a lot of places where plugins continue to be a great solution. And what we're going to do today is talk about some of the cases where you can use plugins and some of the things that you need to look out for. Okay, so before we go on a little further, I'll tell you a little bit about myself. My name is Jim Daly. I've been working with business applications for about 20 years. In the past 15 years, I've been with the product known as Microsoft CRM, Microsoft Dynamics Business Solutions, Customer Engagement, and now PowerApps Common Data Service. So different roles I've played is, I've done technical support, I've done training, I've been a programmer analyst. Recently, for many years, I've been with the content team. Last role I had, I was managing the developer content for Dynamics 365. So if you look at any of our documentation, you may see my little icon head there. So I've contributed to a lot of those. And so for about the past year now, I've been playing a program manager role with Ryan Jones' team. And plugins is one of the areas that I own. So thanks for coming. Let me give you an overview, because some folks have already asked, are you going to cover this or are you going to cover that? So let me be clear about what I'm covering. So at a very high level, we're going to talk about what plugins are and when to use them. I'm going to do a little bit of a dive into how plugins work, talking about the event framework, how they're stored, the runtime behavior. Then we're going to talk about common pitfalls, things like performance issues, dealing with dependent assemblies, some of the issues that we hear about that rise up from customers through support up to our team and get escalated and that we have to deal with, and what we know about. And then the last thing is I'm going to talk a little bit about the efforts that we provided to give more guidance to people, to try and help people use plugins better. So the point of covering a lot of the stuff about how plugins work is so that we can talk in a little bit more depth about the common pitfalls to help you understand what these pitfalls are and what caused them. And I guess one of the first questions I wanted to ask in the audience is try to get a sense of how many people are long-term plugin developers. Can you raise your hand? Has anyone never written a plugin before or just written a couple? Okay, good. So we got kind of a mixed audience, which is going to be a little bit of a challenge because with just 60 minutes, I want to cover some of the key concepts and talk about some of the causes. So we're going to skip through a couple common concepts rather quickly to start with, but there are links in the deck where there are tutorials that I've written that you can go through and get started. So I guess the first thing I want to make clear is, what are plugins? There are two types of plugins, and the naming conventions that we use is a little odd because we talk about plugins, and then there's another type of plugin that's called a workflow extension. All right, so in this discussion, we'll be talking about both of those. So both of them are .NET Assemblies. Both of them contain classes that implement a particular interface or a base class that includes an execute method. And they're both uploaded to the server today using the plugin registration tool. And they are they require using the CRM SDK core assemblies. So that's some of the things that they have in common. A few of the ways that they're different, and I imagined when I gave this presentation I'd be able to point to the deck, but for plugins, you've got an assembly that contains a number of types, a number of classes, and each one of these classes has a name, and then with each class you can register a step. So this is a screenshot of the plugin registration tool, which does a pretty good job of helping you visualize how these are organized by assembly. So the key point is there's plugins, there's assemblies, there's plugins, and then there's steps. And these we'll show a little further, you get registered to particular events that occur on the platform that trigger your business logic. Workflow extensions, on the other hand, are a little different in that they are also assemblies and they also have classes, but they also include input and output parameters. And the whole point of creating workflow extensions is that you can extend the workflow designer. So a workflow designer gives you the ability to create a declarative, no-code business logic. But if you find that you do need to include code for whatever reason, the workflow extension allows you to define the input and output parameters that are graphically displayed in the designer where you can execute code within a workflow. And I'll just point out at the bottom of each one of these slides, you'll see a little link for more information. That'll take you to the documentation on docs.microsoft.com related to that. So, one of the key questions that people ask is when to use plugins. And we do want people to use plugins, and we want them to use them responsibly. And another answer that people have for this question is use plugins when there's no declarative option available. If there's not a no-code solution or a configurable business logic UI, then plugins provide the option. So now there's some other conditions that you want to take into account as well, and we'll cover those later. But the key benefits of plugins is that they're highly performant. If written carefully, they have all the power of the platform and the web services and the SDK, and you can use them to connect to external services. Obviously, the downside is that you've got to be a developer to create and maintain them. And if used incorrectly, they can be abused and they can have a negative impact on the system, performance especially. So these are some of the things that we're going to talk about today. One of the key criteria that we need to keep in mind when we're working with plugins is plugins can run synchronously or asynchronously. And I think we all understand what synchronous and asynchronous means in a general term. I want to make sure that everybody understands that when we talk about a synchronous operation in the common data service, we're talking about something that works within a database transaction. So when a plugin runs in a database transaction and it calls another operation, and that operation has another synchronous plugin, you've got a downstream effect of additional business logic, and an error in anywhere in that, from your code down to someone else's code, can throw an error that caused the operation to roll back. Asynchronous, on the other hand, happens after the operation has occurred. The logic that you've defined gets added to a queue, and then as soon as possible after the operation has completed, then your logic will be applied afterwards. So each operation in that case occurs in a separate transaction. So, one of the key guidelines as far as writing plugins and thinking about how you use them is thinking about synchronous or asynchronous. And, so you'll want to use synchronous when the value returned by the operation has to include the changes that you're applying in your code. The entire operation must succeed or fail. And for synchronous operations, think about the user experience and think about, can this be completed in 2 seconds or less? Okay? Now, 2 seconds, you may think, okay, as plugin developers, those of you know that there's a 2-minute timeout. But the key thing to think about is that your plugins aren't the only ones necessarily running in the system. And so, targeting very quick and light operations that can occur synchronously greatly impact the performance experience of the app. So, whether it's synchronous or asynchronous will depend on if it's a plugin. In the plugin step registration, you will explicitly set synchronous or asynchronous. If it's a workflow activity, you don't explicitly set the step, but the step occurs depending on how the workflow activity is used in the workflow. And there's 2 types of workflows. There's what they call real-time and background workflows. Obviously, these are just another term for synchronous and asynchronous. So if your workflow activity is called within a real-time workflow, it is exactly like a synchronous plugin. Okay, so we dive into when to use plugins. versus other capabilities. We can use this matrix to sort of separate them and describe them by synchronous, asynchronous, or code or declarative. So obviously, synchronous code is kind of the unique place for plugins. There really is no other capability that gives you the ability to have code that works in a synchronous operation. The key thing is we talked before about when to use plugins, when there's no declarative option available. The other consideration is, if you are going to apply special logic for certain entities, right? Basically all entities are kind of the same, but the thing that differentiate the behavior of one entity, a special behavior for entity, is often defined within a synchronous plugin that's registered for that entity. Another use case that is becoming very common these days is you may already know that you have the ability to define a custom action using a workflow designer, right? So it's considered as a type of process. So you create this custom action, and then you can use a declarative tool to define what that action will do. But we're seeing more and more people are just leaving that definition empty and writing a plugin to work on that custom action, because the custom action is actually a new type of message. Now, when you talk about situations where you can use code and have your code run, have your business logic run asynchronously, obviously flows come to mind, and flows can call functions, but plugins can run here as well. And of course, from plugins, you can call out to Azure Service Bus and webhooks and do other integrations that allow code to define your business logic in an asynchronous manner after the operation is concluded. Anything that's declarative and asynchronous is really the unique space for flows and workflows. And then finally, completing the loop. Anything that is synchronous and declarative is really the place, real-time workflows are where you can define those. The other thing, if you're using model-driven apps, is that they have the concept of business rules. And business rules can be scoped to the form, in which case they're using JavaScript within the model-driven app. But if they are defined at the entity level, then they are considered, basically synchronous workflows. Something to keep in mind, because if you are using the Common Data Service as a data source for, say, a Canvas app, and you've defined the business logic as a entity scope business rule in a model-driven app, you may not anticipate that, yes, that logic will apply even in your Canvas app, just like a plugin would. And then finally, when to use workflow activities. These are designed to bridge this gap between the declarative designer and being able to inject code into it. So again, if you build a real-time workflow that has a custom workflow activity, you're in effect creating a synchronous plugin. Okay, so that's sort of a quick overview. I hope at a high level, if you're new to plugins, please look at the links if you download the slides, or you can find them in the PowerApps documentation with the tutorials to learn a little more. If that didn't make sense to you, then I hope you'll be able to drill down. So let's change gears a little bit and take a look at how plugins work. And I think, as I've mentioned, touched on, if you create a custom action, you create a custom message. All of the within CDS, all of our data operations are combined within the idea of a message. And when we were publishing the Dynamics SDK for many years, we would include a spreadsheet that included a list of entities and messages that they applied to. We stopped doing that a couple years ago, but people have still asked for it. So, one of the things that I've done recently, just last Friday, is I went out and I published a little blog post. I'll slide that over here. And this basically is walking through how you can recreate that spreadsheet for yourself, for your environment. So it'll include all of your entities, all of your custom messages. And it's a pretty straightforward, just a method of calling an OData query and exporting it out to Excel. That workbook looks something like this. In fact, it looks exactly like this on my environment. Yours will be different. But one of the key things that this does is it allows you to say, okay, what are the combinations that I can apply? If you're registering a plugin using the plugin registration utility, it queries the system to make sure that you make valid choices, but it doesn't give you an inventory of all the choices that you have available. Just using straightforward Excel filtering, if you want to see which entities are related to the add to queue message, you can very quickly find that it's queue item. If you want to take it the other end and take a look at, say, an entity like account and see all the messages that apply to the account entity, you'll see maybe more than you expected. You expect create, retrieve, update, and delete. You expect probably grant access, modify access, and revoke access, set state. These are all common ones. But if you have a custom action that is composed on the account entity, you would also find it here. Okay, so by querying your system using the query that I've defined here using the web API, you can get that information very easily. If you prefer the other option, that you can use to query the system is similar. You can use a fetch XML query using like the fetch XML builder and execute that query and also view the results that way. So the first point in understanding how workflows work is understanding how messages, which ones exist and which ones are available for you to register. So let's talk a little bit about the message execution pipeline. Anytime one of these messages is invoked, either through working with an entity or not, they will go through the message pipeline. And so when you're registering a step for a plugin, it'll go through this pipeline. And as I mentioned here on the top, each message has a name. It has a set of input parameters, a set of output parameters. And if you're writing code with the SDK, you're going to get generated classes for some messages where it'll have like a create request and a create response. So I'm sure who've written plugins are familiar with that. If you use the CRM service utility with custom action generation, you'll get similar classes for your custom actions if you choose to configure it that way. So let's talk a little bit about what happens when one of these web service events occur. The organization request comes in as sort of a generic definition of any type of request. And so it has a name and it has parameters. And then it's going to go through a series of stages. The pre-validation stage is the first one. This occurs before the database transaction. And the purpose of this stage is to decide whether you want to continue forward. At this point, because the transaction hasn't started, if you decide, no, I'm going to throw an error and not allow this operation to proceed, this is the place to do that. If you wait and an error occurs later in the transaction, you're going to end up with a much more expensive operation. And so it's a good policy and recommended that you would always use this stage if you're considering whether or not to cancel the operation. The next stage, once that transaction is started, you have the pre-operation stage. This is where you may want to amend or make changes to the data that's being passed in for the operation. If you've got an entity, you want to set some default values. This is where you do that. So immediately following that, the main operation is the internal stage. So at this point, up to this point, the only data that you have is the input parameters that are found in the organization request. After the main operation stage is completed, now the organization response is available. And so if you created a new record, it now has an ID assigned to it. And this is the best place if you want to create some sort of automation, if you want to create some additional tasks or some additional data after the fact, this would be the right place to do that. And of course, you're working with, at that point, an organization response. You can also change some of the data that's going to be returned. And if you configure it as a asynchronous plugin, obviously after all the operations occur, that data from the pipeline will be put over into the queue so that asynchronous handlers can deal with it. And one of the things that I've noticed looking at the telemetry of, and cases that have been coming through is, as we mentioned, a step is the type plus the stage. And then when you're doing the configuration of the plugin step, you can also set the execution order. Finding not a lot of people are setting this. A lot of people leave it to 1, which is the default value. And so, this leaves you with a little bit of ambiguity about the order in which your steps will occur. You have granular control over this order. If you set the execution order, or the rank value, you can say, I want this to occur before that. If you leave it all 1, then it's sort of random, because it's literally being filtered on the value of a GUID that is linked to it. So if you want to have that kind of control, if it's important to specify within the stage which order, make sure to set the rank. So that's just a little tip based on some of the telemetry that I've seen. And then I'll come back a little bit here and talk about real-time workflow stages. So if a person defines a real-time workflow, they don't have the opportunity to set a step that's predefined for them. So, and they also can't register it for every kind of message. They have a limited set of messages tied to entities. So they can, if they register a real-time workflow for the create event, it'll happen in the post-operation stage, which makes sense because there's no GUID or anything associated with it. So that's a common place to put it. If they were to put it in the delete event, obviously it has to occur before it's deleted in the pre-operation stage. That only makes sense. If you do an update, you have the option. There's a little controller in the designer where you can say, should it be pre or post? And the reason I mention this, as I said, you've got to consider these real-time workflows when you're evaluating the performance of your system and you're thinking about how they're connected to the other plugins that you're using. What you might not know, and I will document this as soon as I get back. Some people may have guessed it, but if you take a look at the execution order of these real-time workflows, you'll see that the value is set to the minimum value of an integer. So you can set the execution order to be positive or negative values, and the lower value will be executed before any other. So this means that real-time workflows run before your plugins. So that's another thing to keep in mind, and this is set by the workflow designer, and you can't change it. When these values are identical, and I made a note down here below, that the sort order of the entity relationship to the SDK message filter, that GUID value is what determines, is the tiebreaker. So just to make you aware of that thing to keep in mind when you're working with these. So I mentioned the SDK message processing entity. So the other thing to keep in mind about how plugins work is when you use the plugin registration tool and you upload an assembly, that is going to get stored in the plugin assembly. So it's going to have the assembly bytes, the version, all the information about the assembly. The plugin type includes all of the classes that implement iPlugin or the workflow activity class. So these all are stored in plugin type. And then when you have plugins, not workflow activities, but plugins, the SDK message processing step registration keeps all the information about the stage that it's to run in, any configuration data that you pass to it, whether it's synchronous or asynchronous. And I'll give you, this is a little bit of a foreshadowing, because one of the things that we'll be recommending is that you document and keep track of the workflows and the plugins that are running in your environment. And one great way to do this is to query it. So let me jump into that real quick. So again, you can use Postman and write a query against I think I have my other one set up for that. So let me choose a different query here. And I've got all of these queries available to download with the slide deck if you're interested in. So if you want to have a query here, here's a little fetch XML query that you can run to see all of the assemblies and the plugin registrations and the step registrations available in your environment. So if you want to keep track of this, here's basically a query that will run a report that will tell you about it without having to go through the plugin registration tool manually and just make a note of every one that you see there. So having a good understanding of how that data is stored can help you. It's very, I think, enlightening to drill into that and understand that a little better. So once the plugins are registered and available in the system, one of the things I wanted to share with you very briefly is a quick overview of sort of how plugins work internally. And I would say that this is something that you'll never see in the documentation because it's really more interesting than important. There's nothing in here that would change necessarily the way that you write plugins. And in fact, it is subject to change at any time. So this is a diagram that describes the way plugins work today, and I'll walk you through how this works. But I know we're working on a new design for different types of improvements that'll change the way this works internally. So this is, again, more of sort of interest rather than of importance. But whenever a plugin is run, it can be run either synchronously or asynchronously. So we have two different servers. The web server is the one that processes the main operations, so synchronous operations get called from that. The async server is the one that runs those that are registered for async. But in either case, both of them communicate with a sandbox client. Okay, so when the registered plugin step occurs, and it'll communicate to the sandbox client, and the sandbox client is responsible for talking to a number of sandbox servers that are available on the scale group where your common data service is running. So there can be several, 2 to 6 different sandbox servers, and then the sandbox client, through a round-robin process, will select one of these sandbox servers, which will then talk to the host service. And when this data is passed between these two servers, it is serialized. So if people sometimes get errors to say this object was non-serializable, this is where it's breaking. So all the data and the context and information that gets passed between these has to be serialized. On the host service, then it is responsible for managing a number of worker processes. So within the sandbox server, there's generally going to be a worker process that is connected to your organization. There's also a number of them that are free, that are not assigned at the moment, but what happens is and if there's not any available, then it'll spawn one. But I think the interesting part of this is that when the data is passed from the server through the client to the host client to this worker process, it makes the assumption that the plugin code that you have uploaded is there. And if it's not, it will throw an error, an internal error, that'll bubble back up to the to the sandbox client, and it'll say, oh, the assembly that I needed wasn't there. Then it'll push that assembly back over the wire, give it to the worker process, and allow it to run the code. And so this is the cold load scenario that's going to happen the very first time a plugin is registered and run. Now, this may seem a little counterintuitive. Why is it not including that? But it's a calculated trade-off in that it's much more efficient for this first one to load a little slower and then expect it to be cached going forward than it is to send that data over the wire every single time a plugin step occurs. So that's just sort of one of the design considerations. When the worker process gets the assembly, then it's going to take the class, it's going to instantiate it. It's going to take any of the configuration data that you have in there, and it'll instantiate it, and it's got the execute method, and now it's ready to run the code. So if inside your plugin you are performing any kind of data operations, the data operations will be routed to an internal endpoint, this SDK listener endpoint, and this endpoint is dedicated to any operations that occur within plugins. And the reason that it's a separate endpoint is it makes it a lot easier for the system to manage the transactions. So then again, if you perform any operations that trigger any additional plugins, so you can end up with, by design, a cascading set of operations that will flow through. But when the operation is finally completed by the worker process, then it returns back to the web or async server that it completed. And I think the key thing that I want to point out here is that in the worker process, the plugin is cached, and it's not instantiated repeatedly. It is left there and expecting to be there anytime any additional operations come through. And these worker processes stay alive for about 3 hours or so, depending on how active they are. If they're not active, just as part of a resource conservation, they'll be shut down. So again, this is really just trying to explain, some of the internal workings. It shouldn't change the way that you write plugins, but I just thought people have often asked and have expressed interest in how the inner workings operate. Question, yeah? It is very much of a pipeline. So the question is, do the different processes communicate with each other? And no. I mean, they will just run through the pipeline. They'll do that thing. If they'll do their thing, and then again, if they have code, that spins up another operation, which then goes through the pipeline. And all of the synchronous operations have to conclude before that final transaction is completed. So by covering a lot of this stuff, I hope I've set the stage for the rest of the discussion, which is going to talk about common pitfalls. Now we've sort of given you a high-level view of how plugins work. The pitfalls that I want to cover are performance-dependent assemblies, not including stateless classes, error handling, and tracing. So we'll just go through these in order. The first one, and it's a common challenge, is just dealing with the consequences of plugins that have a negative impact on performance. These manifest themselves via slow requests, timeouts, deadlocks, and low throughput. Now, one of the questions I want to ask, and I know at least some of you have read it, how many people have read the Scalable Customization white paper that was written a couple years ago? Good, you're going to recognize some of this stuff. One of the things that we've done is taken some of that guidance that was in this white paper that was written by Roger Gilchrist, who's on our fast track team. He did a deep analysis of it several years ago, and it's still valid. And instead of making it a white paper you have to dig and find, we put it in the documentation right next to how you learn how to do plugins, so you'll be able to discover it a little easier. And the key point of this is that the reason why particularly synchronous, but also synchronous plugins have performance issues usually come down to these things. Very frequently they have queries that are overly complex and expensive, or they are trying to access the same resources. So you have contention for very valuable resources, and that can cause backup of blocking, which leads to long-running transactions, and so you have sort of cascading effect on performance. And these are sometimes quite difficult to troubleshoot and to understand. And so that's one of my key action items for you is to go in and review, if you're going to be writing plugins, go in and review that customization white paper. It has a lot of good examples. For example, one of the key methods it uses is to show several different attempts to do an auto-numbering solution. Now we have an auto-numbering solution, but at the time it was written that didn't exist, so that was something people were trying to do. Many people were trying to do and not being successful because of performance issues. And so it uses that case study and it analyzes some of the reasons why different design choices lead to poor performance. So even though the scenario is one that you don't have to solve, it's a really good case study. One of the other points that this white paper makes, and I hope to impart to you, is sometimes people have the impression that CDS ought to just take care of this for us, right? Somehow I should be able to put whatever kind of code I want in there, and CDS will manage it. And I guess the key point I want folks to understand is it does, as far as it can. Because we are working in a relational database, locking and transactions are important, and they protect the data integrity of the system, right? So they help to protect the system against conflicts. But by necessity, if your data is in the relational database, it's going to be at risk of having some sort of a contention, and locking and blocking are part of that. just as if you were to write your application against your database using stored procedures, you have to take those things into account. Now that you're writing them in C# within a plugin, those are also factors. So one of the key things I want to impart to you is to check your expectations. Realize it is the plugin developer's responsibility to make sure that they get the best performance possible out of their code. Understand the goals of the system and work with it, because if you're trying to work against it, you're going to feel a lot more pain. Don't try to do everything with plugins. Once you understood and you know how to write plugins and you're a developer, there's some benefit in having all your business logic there checked into your source repository. But you may want to say, here's some things that I don't have to do with plugins. And one of the main points is because CDS is a database that is intended to support multi-user app performance, and the performance of the app is a priority, it's really not intended to do batch processing compute. It doesn't, if you're trying to do a lot of iterative processing through your plugins, a synchronous plugin in particular, that may not be the best design or the use case for a plugin. So, the key thing is to sort of analyze what you have and think about what is the most appropriate method to do the work. And, in the white paper that we published here, it gives a really good example, a visual example of what I've been talking about, how the chain of transactions occurs. And a lot of times this can occur by design. It can occur by accident. You can have multiple developers or a developer and someone doing a configurable real-time workflow. So in this example, somebody creates an account. That account has a plugin on the pre-operation stage. Then in the post-operation, it creates an email. That email creates a new record which has its own plugins linked to it in steps. And then an additional, the email has a post plugin, and then somebody has a synchronous workflow. And so all of those synchronous operations tied together make the transaction last a long time. And the longer transactions last, the more opportunity there is for resource contention and locking. So, I recommend go and take a look through the white paper. The link will be in the deck. You can find it in the documentation as well. And it'll help provide a lot more insight into this. We could probably talk for a whole hour digging into this single topic, but I think it would be better spent moving on. A couple things that you can do, related to performance. We've had for a long time, we had an organization insights solution that you could install. And this provided you with some data about the performance of your plugins. Just recently, we've moved out, and now within the PowerApps portal, you'll find a page for Common Data Service Analytics, and one of the things that you can get data on are plugins. And so by monitoring the data that's captured there, such as the success rate, how active they are, how often they execute, the average execution time, all of this is now available for you in the PowerApps platform so that you can evaluate and see which plugins may have performance issues. One of the other remnants of the, I'll tell you a little bit about this data comes from the telemetry that is sent by the system. Okay, so it's based on Custo queries and generated that way. There's another way that is sort of brought along by the organization insights, but it's still there, and I'll just point out to real quickly, is if I take a look at the plugin type statistics entity, I have another query here for plugin type statistics, and you can see here it's a query against that particular table, this returning all the relevant rows, and with a link to the plugin type. So when I execute this query, you'll see my system here. It doesn't have a lot of plugins on it, running on it today. It's just a clean vanilla system. But yeah, you can get a report using data that's in CDS about the plugins that are running. So some of the common causes for performance issues in plugins are, as I mentioned before, expensive database operations. Queries are inefficient. They return more data than they need to. Multiple updates to the same record. You may have one plugin that updates the record, another plugin that updates the record. All of these operations can be consolidated and made more efficient. And then, one of the cases that came up fairly recently, we had to come up with a new error message, was that people would write a query that would, like, for example, query on an operation that had a lot of attachment data on it. Right? So they would retrieve, say, an opportunity with a bunch of attachments that included files on it. And that works just fine as long as there's not a synchronous plugin associated with it. But, and I'm sure when the developer would work on this and write this and test it with 4 or 5 attachments, it was okay. But when there were a couple hundred attachments, suddenly we've got 180 megabytes of data passing through the pipeline. And so now what we do is that if there is a plugin registered and that much data comes through, then we really have no choice but writing queries that can potentially bring a very, very large amount of data with them, and commonly found with attachments because they're so heavy. You might be on the lookout for that, and hopefully, if you do, you'll find a way to work around maybe dividing that up into smaller queries. The other, as I mentioned before, multiple customizations triggered on the same event could be consolidated. Long change of synchronous events can happen sort of organically, so you have to be on guard of that as people are adding new plugins to the system. And also just using the wrong plugin stage. The pre-validation stage isn't a good place to create new records because the operation may just fail anyway, and you've just sucked up some of the time, and it also occurs outside the transaction. So using the plugin stages correctly in the right order is important. So again, the link in the slide here will take you to where we've published this on Docs, and hopefully that'll make it a lot more visible and people will be able to find it. Okay. Now the other, I hesitate to call this a pitfall, but it is certainly a pain point, is dependent assemblies. When you're writing code in your class and you want to communicate with an external web service, it's natural that you would want to use, say, JSON.NET. It is the go-to library for parsing JSON. Or you may want to include the Microsoft SharePoint client library. And yet when you register a plugin, we only allow for a single assembly. So the common solution, and I expect many of you who how many people here use IL merge? Okay. Now the thing about IL merge is it works for a lot of people. We don't block it, but it's not our product. We are not experts in IL merge. And when it is tricky, it's very tricky. And so, what we will support is an assembly, and we won't ask a lot of questions about where it comes from. But if the issue that you're experiencing involves IL merge and you call support, they may say, well, let's take IL merge out of the equation and try and reproduce it. And if they can't reproduce it that way, it's very hard to make progress. And I will say also, I've been reviewing a number of the escalations that have come up from support, and I've seen some of the responses from our support team. Although we do not support IL merge, they seem to know some things about it. So, but it isn't part of our product, and so we can't go. There's a limited degree to which we can go to try and solve problems that involve IL merge. So the recommendations are, for example, there are alternatives to JSON.NET so that you don't have to include the assembly. There's some standard .NET classes that allow you to do that. If you have work that really depends on external assembly, offload those to Azure services, use webhooks or Azure Service Bus. Get that to be processed someplace where you're free to use those assemblies with no problem, and just try and keep your plugins light and fast. The other common issue that we run into pretty frequently is, as I mentioned before, how the classes that contain your plugins are cached. We sometimes see people writing code where they will take in the execution context, they will generate an organization service, and then they'll cache it within their class as a property. And the problem with that is that that's taken from the very first instantiation, which includes like the calling user and other information that was specific to that initial run. But the runs that happen afterwards may come from, or very likely come from different users, right? And in that case, if you're using that organization service that you have cached as a property in the rest of your code, it'll probably run 99% of the time, except it'll seem a little weird. You'll end up with records maybe assigned to somebody who didn't create the record. So, the key takeaway here is that, all the information that you include in your plugin should come in through the execution context parameter of the execute method, and not try to cache anything. You can put constants, for example, as properties, things that don't change, and so we've got, and I'll take this opportunity as well to point you to one of these links in the deck, because this is one of several new topics that have been published. Let me go ahead and get out here. Okay, I'm trying to click that link. Should open here in a minute. Yep. So you'll see that we've also, this is one of the initiatives we're trying to send more information out to people to help them write plugins better. This was really driven by the solution checker, and the solution checker is a way of testing whether your plugins or custom code or anything in your solution follows best practices, and it actually does an analysis of the code in the plugin, and you'll see that there's a whole range of different types of best practices guidance that's available and published here, again, related to plugin development. Now, error handling is another common issue. And this is probably the most common, looking at the telemetry, this is the most common error that we see related to plugins. It says there's no active transaction. The error is usually caused by plugins. Ignore errors from service calls and continue processing. And the reason for this simply is people are trying to swallow errors. Just like if you're writing a console application, you might have a call and put it in a try-catch block and say, this happens great. If it doesn't, that's fine. The problem is if you do that with actions already being rolled back, and any code already being rolled back, and any code that follows that try-catch block is going to cause this error to happen. So this is sort of just building awareness about how these operations occur and how any error at all within the plugin will cause the transaction to end. So if you see this error, whether in code you've written or code that someone else has written, it's a pretty much of a dead giveaway of what they did. The last item I put down here below under error handling is also writing resilient code. And one of the common things that we've seen is that when you're writing your plugin, you get the whole execution context, which includes the parent context. And so the parent context is the whole chain, the upstream chain of operations that led to this operation being called. And we have found that some people have made certain assumptions about the order in which things will be called. If they put for example, a step that is on the update of a quote entity, sometimes the quote is updated because there's a revised quote message above it that updates the quote. And what we found a lot, recently, it was that the people who own the revised quote message changed their implementation. So all these people wrote code expecting to go one level up in the parent context and discover, this is being written by the revised quote message, and then they were broken. If they'd written their code in such a way that it would go all the way up the parent context and see if the revised quote was anywhere in that upstream chain of operations, they would have found it. And so this is what we're talking about, making code more resilient. Don't necessarily assume that it's static. It will be changing and it's always evolving. And Generally we don't recommend people putting a lot of dependencies on the parent context and the upstream information, the contextual information to write their plugins. Some cases it's unavoidable, but if you do, try to make it as resilient as possible considering what other ways it could work, and then continue to test it. Okay. The other point I want to touch on is tracing. As I've been reviewing some of the cases that come up from support, and I've seen some of the code that has been evaluated, I was a little surprised to find that a lot of these didn't include any kind of tracing. And the reasons for that may be varied. People may not be aware of how to use tracing, or they just got accustomed to not doing it. And granted, sometimes the trace view is difficult to find. You can query it pretty easily through the OData endpoint. There are tools like the XRM Toolbox plugin trace viewer that make it a lot easier. So, encourage you to use tracing, because a lot of these cases that I've seen get escalated could have been solved if the person had used tracing to examine the context and understand what's going on. And the other case that we've seen with telemetry recently is that people have been using tracing as telemetry. So tracing is a feature when you use the tracing service. Your trace logs will exist for about a day. Intentionally, this is by design. They're intended to be something that you can examine when you're developing a plugin. You can turn on tracing to do some troubleshooting. And it is technically possible to go in and modify the system job that is in there to remove trace logs more than a day old. And what we've been finding is people have turned off that job, or they have modified it such that, and then they've also left tracing on a verbose setting. So this causes the trace log table to expand, and that impacts performance. So just a little call out. Yes? To turn it off? Yes, there is a system setting where you can set the tracing. Maybe I assume, but yeah, so in the organization settings, you can turn on tracing. You can set it to be off, verbose, or exception only. And so verbose will write all kinds of trace logs, and exception will only write trace logs in the event of an exception. So there's one system setting per CDS instance. Yeah, so it applies to the whole CDS instance. The question is it global, and it's scoped within the CDS instance. And of course, so beyond tracing, a constant problem is, not a constant problem, but a common problem, is updates that are inadvertent, looping updates. And the main way to address this is that when you are updating an entity, make sure that you're only updating the necessary values. If you're registering a plugin on the update event, make sure that you use the filtered attributes list so that your plugin is only triggered when the particular values you care about are changed. So one of the items that I frequently see in blog posts, and there's a lot of great information in blog posts written by the community. But one of the things that I've seen mentioned a couple times is people really focusing on the execution depth property to determine where they are in the chain of a series of operations. And the key thing that I want to call out to folks is to make sure that you understand this is not guaranteed to be consistent. It can change over time. The implementation that's done upstream could be very different. So you can't make that criteria for your business logic. And then the last point I would make here, and tying back to the queries that I showed you about how you can understand what's in the system, is a good way to avoid looping updates is to review the customizations that you have in your system and analyze how they may impact each other. And then this slide, basically, all the links that I've called out, if you download the slide with the presentation, or you take a snapshot and go back and type them in, these are the information that we have. The tutorials have all been rewritten fairly recently to allow you to be able to hand this to a developer and say, here, write a plugin. It'll give you the basics. The best practice guidance is there. Got new guidance there about troubleshooting plugins, and again, the scalable customization white paper. So, I know we've got about 4 minutes left, and fortunately we got it all in the period of time. So we've talked about what are plugins, when to use them, how they work, and some of the common pitfalls, as well as showing you some of the additional guidance. So we've got 5 minutes before people have to run, so I'm happy to take questions, and then Sean McNellis is here in case there's really hard questions. Oh. So is this a synchronous or asynchronous? Synchronous plugin that creates over 1,000 records. What's the? Yeah. I would love to know more about the story about that. Maybe we can cover that quickly. I will just go ahead and put forward the slide here and ask you, before you go, to please evaluate the session. But I'll come down here and we'll deal with any individual questions that people have. Okay. Any broad questions we can cover before drilling into that one? Yes. Everybody wants the developer toolkit, and work is underway to finally update and provide a developer toolkit. Last one was released, 4 years ago, the official developer toolkit, and requires 2015. I imagine some people are still using 2015, but yes, we've got a team of developers now, finally, who have that goal. They've been working on the plugin, the PowerApps control framework tooling, and now that that's gone into public preview, they have the bandwidth, so we'll be able to drill down into working, and plugins is next on the list. Any other quick questions? Okay. You can update it, but you have to update the assembly as well. Yeah. Okay. Yeah.
And by the way, that is a best practice to keep as much in one assembly. Jim covered the caching.
Yep.
How we do it on the worker, and then time.
Yeah. Until the size of the assembly gets over 16 megabytes, that would be the maximum size. It's an entity reference, right? So that comes through. Okay.
We have to say none. So every time any entity type, there's a shared, there's a associate, this plugin will trigger. So we handle that from within the code to execute it for the entity type.
Yeah, because it's an entity reference that comes in. You can't filter it by the entity. You have to examine the parameter being passed in, which will be a entity reference, and the logical name is included in that. So you just have to put a bunch of if statements to deal with the ones that you care about.
So still we have this, right?
What's that?
There's no change on this.
No change intended that I haven't heard about it. Actually, it's the first time I've heard of this as an issue.
Okay, and we have an issue now also. So when we move the solution from environment to environment, sometimes for some reason the steps not move.
Okay.
So we have to create the step.
So within the solution, when you migrate it, there's a setting that it should activate any plugin steps. They all have that set. Okay. I mean, I would raise that as an issue to support. Have you contacted support about that? Okay. Well, let me know when you do, and I'll follow through and track that one. test the execution order for the plugins in one assembly?
To set the execution order.
To set it in the assembly itself? No, it's part of the step registration. So that will be the only place that you can set it.
When you set your steps, so you set it up, you export it, you put it in solution control, and then you build your solution and deploy that same solution to your different environments, right? When you do that, set your registration step or set the order in the initial registration, that way you can deploy it forward that.
The steps is for the same plugin, right? But if I have like a step in every plugin, but I want to set the execution order for the plugins itself.
Yeah, you set it, the step will fire the plugin. Yeah, you need a step for each thing you're firing. So you say, I want this to fire first, and then you can set that, or it'll order it itself.
Okay.
I think there was a question, Jim, in the back corner.
Okay, well, we'll come back to you. Okay, so the question is, how long is the workflow engine going to live? You know, the workflow, the whole capability of workflow, you'll find all the documentation has sort of been owned by the flow team now. And so they call these classic CDS workflows. But really what they control is the designer. You know, all the inner workings of it are part of CDS. They have told me that they have plans on sunsetting the CDS workflow, and I think what they're talking about is the designer within the customization tools of CDS. They're going to provide a designer within Flow, but ultimately it'll still be working the same way. And I've talked to the dev team about that. They are going to be pulling the definitions of the custom workflow assemblies from CDS and displaying them within the Flow designer. So I've heard, you know, when you say, oh, they're being sunsetted, I think they're only talking about the designer. The designer will be moved to Flow, but I've heard nothing about removing them as a capability. Okay. Good. Okay, not good, but yeah, let's hear it.
The plugin tracelog. Is there any way to customize the form because the section of execution, I mean the field of message block is built.
You know, I wouldn't even bother trying to look at it through the form, frankly. I would use the plugin tracelog viewer from the XRM toolbox, or I would query it directly using the web. It's just too many clicks. I mean, it's a good idea, and there was a bug for a long time where it was blocked. But I would recommend, you know, not trying to make that work.
And what is the entity type of execution? Because we couldn't find fields.
This plugin tracelog is the name of the entity. I don't think you can customize the fields in it. Are you talking about
Try to retrieve text, the data from message block to field.
Yeah.
We couldn't find it in any.
Plugin tracelog.
The plugin
There's no field of message block.
Get all the fields from the attribute, and all the fields that are visible are in the entity. You can pull it through API, through PowerShell, through the plugin trace viewer and XRM toolbox. It's probably the best way that you can do it, in my opinion.
Yeah, I mean, I'd like to provide an out-of-the-box way that's better than that, but for right now, it's the best one. Okay. Great. I know some folks need to get to the next one, but I'm happy to stick around, and we'll just come down here, and thank you.